Good morning, all the students. How are you? I hope you all are best and fine. Yes, now we are going to discuss about our concept of measurement and heat. In this, already we have discussed yesterday what is the nature of expansion and as well as the contraction of our liquid. One thing we consider when we are provide the heat to the system of heat or otherwise heat to the system for any of a material system of materials like liquids or gases or solids compulsory they are changes their lengths, they expands. When we produce the heat, they expands. When we taken the heat from it, means what? When we cool down, it will be may contract. Clear or not, all the students? You know very well, so many applications are there like this. Suppose when you check our electrical pole wires, they taken not it is into the fit manner. The electrical wires are not taken in a straight line manner. They are taken in the form of a curves. Why they are taken in the form of a curved lines? Why? Because due to the heat at the summer or otherwise due to the heat at a cool at the winter and as well as normally when the electricity that flows through it automatically they heat it. Okay, because of that heat may they are expands or contracts when we provide the cool to them. Okay, clear or not, all the students? Yes. Because of that, there is what will we get for us? Because of that, there is will get for us is information about expansion and as well as the contraction. One thing there is whatever our tracks are there, which tracks? Train tracks. They also contain the space between the one track to the one particular iron track to the another iron track, and not a continuously we are considered. There is somewhat space, light space is there between the along the track of whatever the track lines are there. Okay, why? Because we are taken that. Why? Because there is a what due to the heat that whatever iron track are there may it is somewhat times contract, somewhat times expand. Okay, clear or not, all the students? Like that only there is a going on. Okay, now contraction and expansion of materials. Yes, that is applicable not only for the solid, it is also applicable for the liquids also, and also applicable for the gases also. Okay, clear or not, all the students? The gases are expand for the heat, and as well as there is liquids are also expand for the heat. Got it? This is only about our yesterday's concepts. Why? Because already we are discussed. Already we are discussed. Why? Because there is a solids are contained very nearer to one another. The solid particles are contained very nearer to one another. That's why they slightly expands. Not expand that much. They slightly expands. Okay, now compare with the liquids. Liquids are contain random motion of a particles inside of the liquid. That's why they easily expands. The place is available to move from one place to the another place in the liquids. That's why they are easily expands. And come to here our gases. The gases are not expand that much of easily. Okay, they takes the what? They takes okay, now yes, sorry, the gases are easily expand, then the what? Then the solids, then the liquids. That is only the thing we are consider. Yes, clear or not, all the students? Here, when we take here the solids, they contain very nearer with another molecule is nearer with another one. That's why when we provide the heat, automatically there is a what? They expand, they absorb the heat, and whatever the small place is there, the small place is only there for the move from one place to the another place. Suppose you take the liquids, there is a what? They contain the what? Molecules are not that much near. Yes, compare with the solids. That's why they easily moves from one place to the another place. Okay, this is not there in our textbook. Okay, now yes, and here I am taken here the heat automatically. The particles are moves easily from one place to the another place. Because of that, they expand. That looks like an expand manner. And when you take here our gases are easily expand. They contain the less number of molecules in a small place. When we produce the heat to it, okay, in the form of a heat, when we produce here, yes, they easily expand in a different manners like this. Got it? Got it or not? This is only about what actually, this is only about our concept of heat. Okay, this is the expansion and contraction of the materials for the heat. And the same thing we are considering in experimental manner. Okay, we take a flask and as well as the one vessel. Yes, in the flask initially we are taken a what? Cold water, and in a vessel we taken a hot water, and you take a capillary tube and through the rubber cork we send that capillary tube into our flask. The colored water rises in the capillary tube. Okay, up to some particular height initially when we are not produced hot water. When we produce the hot water, automatically the capillary tube, whatever the level of our colored water is there, that is increases its height because of expansion nature of liquid. And when you taken out our flask from that hot water vessel, suddenly there is our capillary tube water level decreases. The capillary tube water level is decreases. Okay, clear or not, all of you? And that is only we have to take in here. Yes, expansion and as well as the our contraction of expansion and contraction of liquids. Here we take here, that is only the topic. Yes, expansion of liquids due to the heat they are already completed. Expansion of the due to the heat is completed. You know very well now. Okay, now you are satisfied with this experimental observation. You are okay with this expansion or not? Expansion is going with the expansion is going with our heat applied on our liquid or not? Yeah, it is expanded. That is the page number. We go with the page number 46, and the topic is, now we are going with the properties of mercury. Now we go with the properties of mercury. Yeah, there is a before going to that we have here what the thing is there here. Why we are not use the water? Why we are not use the water in our thermometer? Why we are using the silver thing in our yes our thermometer? Okay, why we are used a silver thing in a glass bulb in our thermometer? Why we are not use the water? Okay, yes. What Mr. Sridevi Prasad? Who's that? Why are you coming to the class? Huh? You want to know about your friends? Huh? Please delete that messages. Listen carefully the class. Okay now. My side is everything clear. The sound is clear and video is clear. Once secure internet connections. Don't write anything. If it is anything is there, myself I am only asking you, yes, for the clarification if it is okay or not. Yes, my side is everything is clear only. Don't write any other matters. We are going with the seriously of the class. All the students listen carefully here. Why we are not use the mercury and why we are use the mercury? Why we not go with the other liquids? Water is there, milk is there, okay now, so many liquids are there now. Why we are go with that things only, mercury only, why we are used for the measuring the temperature. Okay, yes, and here there is when you go for here mercury, when you go for here mercury, yes, mercury contains some special properties. What the properties are there for the mercury? Once we have to check here. It is expand in uniform manner. Expands in uniform manner. Okay now? Yes. What is the mercury actually? The mercury, one of the element, it is a metal actually. Actually, it is a metal which is a contained in liquid form. Which is a contained at a liquid form. At where? At normal temperatures, means what? At room temperatures. Clear or not all the students? Actually metals are in which form? You know very well, metals are in which form? Yeah, metals all are in a looks like in a solid nature. Metals are looks like in a solid nature. Okay, and but our metal of mercury is not in looks like in a solid nature. It is in a liquid nature at where? At room temperature. Yes, but our remaining metals are required high temperature. Suppose you take our gold. Gold is getting in the form of a liquid. No, it is in the form of solid. Silver is getting in the form of a liquid. No, it is in the form of a yes. No, it is in the form of our yes liquid. It is in the form of solids only. But our mercury is getting in the form of what? Liquids. It is only the property it is the first property. Okay now? It is only the first property. We are used for what? We are used for what? We are used for our yes temperature measurement purpose in a thermometer. Clear or not all the students? Just there is a because of our yes because of our liquid nature of this metal only, fundamentally we are used for our yes what purpose? We are used for our thermometer purpose, for the measuring purpose. And as well as the mercury is contains of what? Mercury is contain one of the property that is expands uniformly. Mercury expands uniformly with the temperature. Uniformly means what? For every degree centigrade, for every equal heat, it is equally expands. Okay now? Yes, the heat is measured in which things actually? Heat is measured in calories or otherwise kilocalories or in joules. Okay, clear on all of you? These are the units for the heat. Okay, now when you provide equal heat, there is a what? Our mercury is equally uniform. Suppose you know very well when there is a 1 degree, say 1 degree Fahrenheit, suppose actually normally the mat contain how much temperature? 98.6 degrees centigrade. The healthy man is a contain 98.6 degrees centigrade degree Fahrenheit temperature. Okay, clear or not all the students? And for every 1 degree heat, the mercury rise its level equal only. Okay, suppose in our thermometer there is it is a level of mercury. It is a level of mercury. It is this line is indicate the level of mercury. Suppose you take here, this is only the line of indicates level of mercury. And this is the capillary tube now. The capillary tube, suppose it is a 98.6 degrees Fahrenheit. It is a rise, it is at this particular temperature. Suppose it is a travel what? Up to here 99.6 degrees centigrade, it is expand this much. When it is reaches 100.6 degrees centigrade up to this distance, means what you understood here? For every 1 degree difference, it will be reaches the what? Same height only. Same height only. Understood or not all the students? For every 1 degree, it will be expand uniformly. Okay, now clear or not all of you? There is a no change. In case it is a 1 degree, one type of a change, then the 2 degree for another type of a change. It is not like that. Suppose you take water, it is a different. Okay, now when you take a 0 to the 1 degree, it is a one type of expansion is there. 1 to the 2 degree, there is another type of expansion is there. Suppose you take a 99 degree centigrade to the 100 degree centigrade. Okay, now when you take a water at 99 degree centigrade, it is a what? It is a what in a liquid format. When you take here, it is 100 degree centigrade. Suddenly it is converted to vapor. Water it is at 99 degrees centigrade. The same water when it will be come to the 100 degrees centigrade, it will convert as a vapor. What you understood from this one? For every 1 degree centigrade, it is a not changes equally. Okay, clear or not all the students? 98 to 99 also water only, but 99 to 100 it is a convert as a vapor. That is only called uniform. That is only called uniform expansion. Okay? Yes? Uniform expansion. All the students, once again I repeat it, during the classes the doubt clarifications are not possible at middle of classes. Already I am given, yes, at last 10 minutes I want to go for the doubt clarification. Why? Because in case during the class I am going to the doubt clarification, the lesson is become disturbed for us. Okay now? Yes? And now, there is a what? Understood or not all the students these things? Expands uniform. Expands in uniform manner. When we heat that our mercury, okay now, it is expanded. Yes? Why? Because it is in a liquid format now. It is expanded. But in which form it is expanded? It is expanded in uniform manner. And the next to come to the second point of the property. Yes? It is opaque. It is a work opaque for the light. It is works opaque for light. You know very well what is opaque media. There is a based on the light propagation, the media are classified into how many types? Based on the light propagation, the media are classified into how many types? It is classified into this. How many types? 3 types. What is that? Opaque and transparent and translate. Okay, clear or not all of you? Translate. Opaque, transparent and translate media. 3 types of media are there. Okay, what is the 3 types? Transparent and non-transparent, that is only called opaque, and partial transparent, that is called translate. Our mercury works as a transparent media. Then what is the use of a transparency in case? Yeah, there is a light is not passes through it. Because of that, it is easily observed at temperatures. Okay, in case light is may possible to go that one, it is not possible to yes, take the readings. That's why it is easily, okay na, yes, measure our temperatures like this. Once you take our thermometer in this one, yeah, yes, when you take here there is a, my finger, this portion is appear for you, this portion is appear for you, otherwise this is appear for you, this whatever green color thing is there, it is appear for you, it is not appear. Why? Because it is a mercury, na? The mercury is works as a opaque. That's why only it is not allow the light through it. Clear or not all the students? It is not appear, na? The green color is not appear. Normally that is appear the green color thing, but it is not now appear for us. Understand all the students? Why? Because it is not appear. Why? Because our mercury works as a opaque media. Okay, now what is the use then in case it is a opaque? Yeah, when you take here we want to take the readings. We want to take the readings. Yes, there is a what in case it is not a opaque media, the back side is also appear for us. Okay, clear or not all the students? Automatically that taken the reading, it is a somewhat a disturbance. Why? Because suppose the light is passes through it, where the reading is there. Okay, now where that hour it is appear, actually suppose one check it here. Now just a minute. Yeah, one second here. One second here, there is a what already reading is there, that whatever our mercury is enter into the, yeah, it is not seen for us. Yeah, now it is clear or not? Yeah, now it is clear. Once check it out. Here, whatever that capillary tube yellow color is there now, in that one it is a rises. It is a rises or not? Wait for 1 minute. Yeah, here it is actually this part is work as opaque here, and now when you take here very near to it automatically, yes, there is a whatever the things are there, somewhat it looks like in a black color. Okay, now the yellow color is not appear for us, it looks like in a black color. Got it or not? Yes, it is a looks like in a black color. Why? Because it is works as a opaque, it is works as a opaque here. Yes, it's not clear actually. Okay, now we'll take later, it is clear purpose. Just wait. Yeah. It is a waste of our time. There is, sorry students. Now there is simply when you check here on this particular our thermometer, whatever the liquid is there here, it is a rises. Okay, clear or not all the students? It is a rises suddenly up to here. Okay, now this place, whatever they here, it is not up here. What is the back side of this one? Okay, why? Because it works as a opaque. Automatically, the remaining things are all transparent. In this one, remaining things are all transparent or not? Everything backside, whatever the things are appear. But only the mercury the works as opaque. Automatically, it will be gives the easily the readings are gives easily. Means what? It is rising up to here. It is up here. Because of what? It is opaque nature only. Rising up to here only, it is up here for us. The rising level is only up here. What is the back side of that rising level? It is not up here for us. Because of that, there is easily we are catch our readings. Understood all of you? This is only the nature they are considered for our yes our mercury. This is the one more very important property of the mercury. It is taken as our thermometer. Got it or not? It is only the very important property. Opaque nature is required for us for that measurement purpose. There is expansion property is required for us. Equal changes for equal heat change. Why? Because we are measure for 1 degree, measure for 2 degree. Yes, the degrees are we are taken equal. That's why in case it is a non-uniform expansion, in case it is there in a mercury, it is not useful for us. That's why for every equal amount of heat, it is equally expansion. And as well as it is not above the light. That's why whatever the transparent things are there around us, that transparent things are easily appear. Okay, na? And but mercury, whatever the backside of mercury is there, it is not appear. Because of that, easily we are clarify about the level of mercury. Then come to here. Then one more component. What is that? It does not stick the side of the glass tube. The mercury is not stick with the glass. It easily moves on the substances. You know very well about the mercury. It is easily available in our whatever the scientific things are who sold the scientific things, with them they are available. Yes, and in a bookshops are also available. Okay, clear or not all the students? Here when you take here our mercury is on the particular glasses. Okay, now this glass material is easily moves from one place to the another place, and it will be not touch with that, not stick with our yes glass things. Okay, like water. When you take a water on the yes our that glass whatever the glass we are glass bulb or glass tube we are taken, it is easily moves, it is easily stick somewhere, the water is stick somewhere. But our mercury is not like that. It is what yes, easily moves and it is not stick with the glass material. That's why only easily moves through the our capillary tube. Clear or not, all the students? When we heat it, automatically easily moves. It is not stick with that our glass tube. Okay, clear or not, all the students? It is a contain high elasticity nature. Yes, high elasticity nature. That's why it is easily moves on the surfaces. Okay, and now next to come to here, that is the third point. This is the second point. This is the first point we are considering. And next to come to here, there is a fourth component. What is that? It is a good conductor of heat. It is a good conductor of heat. Good conductor of heat it is. What is a good conductor? What is a bad conductor? A conductor means what actually here? Which is a conduct through it. The heat is a conduct through it. Means what? Heat is a passes through it. Okay, right? It allows the heat easily. Somewhat not allow the heat easily. Clear or not, all the students? Everything is also works as a good conductor. Suppose you take a bakelite plastics. Whatever the vessels we are used in our home, in a kitchen, there is a container what actually for the handle purpose we have somewhat black things are there now. You know very well. Our mom whatever the tea bowl, tea vessel, otherwise somewhat a cooker. Okay, they contain handle as a what? One of the black material. That black material is not conduct the heat now. Suppose you touch once. Don't touch it is like that. Once you touch there is our whatever the panel is there on our cooker. Okay, once you don't touch, you go just to touch. Okay, you will get the somewhat hard sensation. But when you go for our handle of our cooker, it may not give the heat to you. Clear or not, all the students? Why it is not conduct the heat easily? Okay, now clear or not, all the students? Not conduct the heat easily. And but our whatever the conductor we are taken like a iron or otherwise a steel, they easily conduct the heat through it. Conductor means which allows the heat through the material. Okay, that is called the conductor. Allow the heat through it, flow through it. That is only called the conductor. Which is not allows the heat through it. It is called bad conductor or insulator. It is also called insulator. In case it is a partially conduct through it, it is called semiconductor. Okay, clear or not, all the students? It is also called a semiconductor or partial conductor. Understand all of you students? Yes, already I am given example to you. Suppose when you take here this thing, sorry. Yeah. Suppose this material, whatever the material I am taken for the screwdriver, okay, now this component, it conduct the heat easily. It is not conduct the heat easily. Like these things are available. Okay, clear or not, all of you? In your home also available. Okay, now you take here. Suppose when you heat it, okay, now when you heat it through this candle, when we heat it here, it is easily conduct the heat. When you touch after heat it will be give somewhat heat sensation. But when we touch here, when we heat it will be, when we touch it will be somewhat bubble will be get on this our skin. But when you go for here, yes, here it is not gives the heat for us. Why it is not give the heat for us? Why? Because it is a bad conductor. It is not allows the heat through it. Okay, clear or not, all of you? But it is allows the heat through it. Okay, in our home there is so many appliances are there, not all. Kitchen vessels are, utensils are there now. The utensils are contains at ends for the handle purpose. We have somewhat black material. Okay, now why? That is our whatever the vessel material like a steel or aluminium or iron it is there, it will be allows the heat. But whatever the plastic material like a bakelite it is there, it is not allows the heat through it. Okay, that is called a bad conductor of heat, and which allows the heat, it is called good conductor. Our mercury also allows the heat flows through it very easily and in a good mode. That's why it is called good conductor. It's called what? Good conductor. Okay, got it or not, all the students? Yes, and here this is about next property of mercury. And next come to here our next concept. What is that? Our mercury easily available in a pure state. Okay, now it is easily available in a pure state also. Okay, now yes, you know very well all the metals are not available in a pure state. Okay, clear or not, all the students? All the metals are not available in a pure state. Some metals are not available in a pure state. Okay, some metals are available in a pure state. Okay, suppose you take iron. When you extract from the ore of iron, it will be not available in the pure state. You know very well gold also. Gold is also not available in a pure state. There is somewhat impurities are there when you take here from the earth, from the extract of its ores. But our mercury is not like that. It is easily available in a pure state. Okay, clear or not, all of you? That's why, because of these 5 properties only, our thermometer contain mercury as a main material which is measure the temperature. Okay, clear or not, all of you? Silver, gold and so many metals, aluminium, these all are not available in a pure state, but our mercury is available in a pure state, yes, in our environment. That's why these all are easily, yes, because of these good properties only, our mercury works as a, okay, yes, temperature measurement purpose. Okay, got it or not? Yeah. There is platinum is also not available in a pure state, but it is available. It is a very cost, and as compared with other metals, our mercury is somewhat in a cheap metal. Okay, now yes, and that's why it is a very easily we have to use. Not that much of cheap, but it is cheap compared with platinum or otherwise gold and all these things. But all that the platinum, gold and remaining metals are not contain these properties. Okay, thank you students, and here homework for you. Okay, now homework for you. You write the properties of mercury. You write the properties of mercury. You write the properties of mercury. Yes, in your classwork you write the properties of mercury. Okay, thank you students. Bye. Take care.